Welcome to Ask and Learn.
All right, guys, we're doing problem 20 of chapter 8 in Chemistry Essential Science. So I've drawn the stable configurations of neutral atoms here, and they want us to look at their ions and see which of them have noble gas configurations. So we'll start with cadmium. We're going to convert this to cadmium 2 plus. We're going to put, I might as well just do this. That's phosphorus 3 minus, zinc 4 plus, and ruthenium 3 plus, arsenic 3 minus, and silver plus. So let's look at what we have here. So cadmium 2 plus, we're going to lose 2 valence electrons. So we're going to lose these 5 s electrons. For phosphorus, this is incorrect. This should originally be 3, and then we're going to convert it to 6 because we have to add 3 electrons. For zirconium, we're going to lose 4 electrons, so we're going to lose both our d and our s electrons. For ruthenium, we're going to lose our 5 s electrons and 1 of our d electrons. And for arsenic, we're going to add 3 electrons to our p orbital, so this 3, that will now become a 6. And for silver, we're going to lose 1 electron, so we get rid of that 5s electron. Now let's determine which one have noble gas configurations. So which ones have filled valence shells? So we don't have any electrons in our s or p shells, so this is not a state. So this is not a noble gas configuration. For phosphorus 3 minus, we have 2 electrons in our s and 6 in our p. That is a noble gas configuration. For zircon, this is a noble gas configuration by definition because this krypton in brackets means that we have a noble gas configuration. Ruthenium, we have 5d electrons under our valence shell, but we don't have any in our s or p, so that's not a noble gas configuration. Arsenic, we've filled up our s and our 4s and 4p valence shell, so that is a noble gas configuration. And with silver, we've filled out our 4d, but we have not filled out 5s or 5p, so this is not a noble gas configuration. So the basic setup of this is basically just find the original electron configuration, then add or subtract electrons when appropriate to find your noble gas configuration.